Okay, so now, as I said, like we are going to see just the basics of what is required to run the Kubernetes. Okay, so I have Minikube on my box, right? So that is running directly installed on my Mac OS. Okay, so now, okay, so everything is installed on my box. Okay, so now how to make sense of these tools, Minikube, kubectl, and virtualbox, right? So that's why you have to look at this picture. So what is virtualbox, right? Virtualbox is a software hypervisor. So a hypervisor is something that enables multiple guest operating systems to run independently on the host operating system. So what is the host operating system? Host operating system in this case is my Mac OS X, which on which I have installed a Linux virtual machine. Okay, so VirtualBox in this case acts like a software hypervisor, and it translates the calls made to the Linux VM and relays it into the host operating system. In my case, it's Mac OS X. So VirtualBox delegates between Linux VM and Mac OS X. Okay, so now who provisions this Linux VM, right? Linux VM is provisioned by the Minikube. Okay, and inside this Linux VM there is a single worker node. Okay, so the worker node has one pod. Okay, what the pod has the containers which you want to provision. So in our case it has three containers, the nginx, the spring boot application, okay, and the python applications. It has the three containers. Okay, so now how are we going to communicate with the API server? We are going to use the kubectl to communicate with the API server, and API server is in turn going to communicate with kubelet. So minikube is what provisions the Linux VM. Okay, and then the API server communicates with the scheduler and control manager. So whenever the scheduler sees there are fewer pods or fewer instances of the pods, it provisions more pods. Okay, and the same thing with the controller manager. So both Kubernetes control manager and scheduler are part of what we call the Kubernetes master node. Okay, the node which is referred here is nothing but a worker node or minion. So when we provision Minikube, see it is just you look at these messages stopping Minikube in VirtualBox, and then when you say Minikube start, it brings up Minikube and it prints up some detailed messages, which kind of gives you a hint of what Minikube is. Now let's do Minikube start. While we wait for that, we can just open VirtualBox here, right? Okay, see this VirtualBox. This is VirtualBox here. So this is Minikube operating system Linux. You see, ZX file system. Okay, display, storage, audio, network. So this shows that what Minikube is, and it's basically nothing but a Linux VM. Okay, uh, so base memory what is allotted to the Linux VM. Okay, so okay, it shows the terminal now. So this is the VM. So these things kind of give an indication of what Minikube is. Okay, so now we have it running. So now it's preparing Minikube IP address. So configuring Docker as the container runtime. So it can either configure Docker or RKT. There are many other container engines which can be provisioned. So Docker is just one of the available container engines. So now we see the message waiting for pods API server. So API server is again a component of the master node. The master node has these components, right? API server, scheduler, Kubernetes control manager. So later a new component called cloud controller manager is added, but again we will look at it more in depth. Okay, so then it kube proxy is part of the kubelet, which is nothing but the worker node, and kube proxy is it's again like part of the ingress through which different worker nodes communicate with each other. So now, see if you look at the message, kubectl is now configured to use Minikube. So now if you use kubectl on your local, it is going to talk to the Linux VM which is created into your box inside your box. Okay. So much for our working environment. This is going to be our developer environment when we use Kubernetes.